Assalamualaikum warahmatullahi wabarakatuh, and good afternoon. So today we're going to discuss on chapter 2, Sinusoid steady state analysis. So let's look what we're going to learn in this chapter. So we're going to look into nodal analysis, mesh analysis, superposition theorem, source transformation, and Thevenin and Norton circuits. So basically, this analysis or this topic is already been discussed, and you have already learned it in electrical principle 1. So the same concept, the same analysis will be implemented in this sinusoid steady state analysis circuit. So for this week, we're going to look into nodal analysis. So let's look into what is nodal analysis is. So it is the basic of Kirchhoff current law. So in nodal analysis, we are interested in finding the node voltage. So we need to know how to identify the nodes and how to identify the ground also. So given a circuit with the N node without voltage source, the nodal analysis of the circuit involves taking the following 3 steps. So there are 3 steps to determine the node voltage. So the first step is to select a node as the reference node. So assign voltage V1, V2, and so on as a single node. So the voltage are referenced with respect to the reference nodes. And then we apply the KCL to each of the non-reference node. So use Ohm law to express the branch current in terms of node voltage, and then we solve the resulting simultaneous equation to obtain the unknown node voltage. So we also need to know that the current flows from a higher potential to a lower potential in a resistor. For example, if we look at this circuit, how many nodes that this circuit have? So the first thing that you need to know is to find the ground, which is this is the ground node at the bottom here, and then we have a V1 or the first node at this point here. We have 4 branches attaching to this node, and then another node is over here, which is the V2 or number 2 over here, which has 3 branches, 3 wires connected to this node. So if we want to determine the current that flows through R2, so we can use this equation. So the current flowing through R2 is V1 minus V2 over R2. So then we can get the I that flows over here. So I hope you understand a bit on this, and if you couldn't pick up, it's better for you to look back into the electrical principle 1, the example from the last semester. So another thing that you need to know is supernode. A supernode is formed by enclosing a dependent or independent voltage source connected between 2 non-reference nodes and any element connected to in parallel with it. So basically, if you look at this, there's this basic over here. If you look at this, if you look at this circuit, there's a 3 node over here, non-reference, V1, V2, and V3, and the bottom of the circuit is the ground. So there's a single reference node over here. So if a 2 node, between 2 nodes there's a voltage source either dependent or independent. So we can conclude that this two knot is a super knot, a single super knot. So I'm going to explain a bit further during the example after this. So you just need to remind that if there's a voltage source, independent or dependent, between two knots, so it will become a super knot, so that it will be easier for you to analyze the circuit. So another thing that you need to know is how to use Cramer rules to solve multiple or simultaneous equation. So we can use the Cramer rules manually, or you can use calculator, no problem. If you're using calculator, you have to use scientific calculator. You can press mode a few times, and you can, if you press mode a few times, you will see EQN in the screen, calculator screen, and choose EQN, and it will ask unknowns, how many unknowns you have, how many equations you have. So if you have 3 equations, so you just press 3 and key in all the info or the numbers inside, and you can automatically get the value that you want. Okay. Okay, let's look example 10.1. You are given this circuit consists of voltage source, dependent current source, and we have inductor, capacitor, and resistor. And the question asks to find Ix in the circuit, which is over here, and this dependent current source is depend to this Ix over here. So the first thing that you need to do is to change to phasor form. So all of this info here, you need to change it to phasor form. So you need to remember the thing that I discussed in chapter 1. So how we want to change from sinusoid to phasor. So for example, this voltage source 20 cos 40, if you change to phasor, you get this value 20 angular 0 degree with W is 4 radian per second. IH, the inductor and the capacitor, you need to change to the phasor form. In this is in rectangular form, JWL, or capacitor 1 over JWC. So you get this value over here. So W, we use this 4 over here, 4 radian per second value. L is the value of inductor, and C is the value of the capacitor. So now replace the value, the phasor form value, into the circuit. So here is the voltage source is 20 angular 0 degree. This capacitor here is minus J2.5. This inductor here is J20 ohm. Resistor is 10 ohm. Another inductor is J4 ohm. And then, because we want to solve it using nodal analysis, so you need to determine the nodes. So first, the reference node is at the bottom here, which is the ground. And then we have a non-reference node, which is over here and also over here. So it has 3 branches here, 1, 2, and 3, and for V1 also 1, 2, and 3. So we have node 1 and node 2, and we define this node here is V1, and this node over here is V2. So the next step is to apply KCL, Kirchhoff current law, at each node. So let's look into the node 1 first, which is the V1. So we have to to determine the current flow. So you can assume the current flow in any flow you want. So for this, it's better the current flow is from the voltage source, which is I, and then from this node here it goes to the ground plane, the ground node, the reference node, which is going down, and this branch here, the current goes to V1 to V2 over here. So using KCL, after you draw this using KCL, so we know that I here is equal to Ix plus I1. Okay. Okay. So after you get the KCL value equation, you need to insert the value of V over R. So I equal to V over R. So here is V over R for I. For I, this is V over R for Ix, and this is V over R for I1. Okay, this I1. So let's look for I. So V is basically because there's a current source. So because we have a current source over here, so that's why we have 20, the magnitude here, voltage 20 minus V1 over R, which is 10. And then for Ix, we will get V1 minus 0 because it goes to the ground plane. So it goes to, we need to minus 0 over minus J 2.5. And another one is that current goes from here to here, which is I1. So V1 minus V2 over J4. So that's why we get this value. So the same concept used in electrical principle 1. Okay. So after this, you get all this value, you can simplify it. So first you remove this value over here, 10, so it goes to the right side, and then you do the operation plus and minus over here, and you get this value. So basically over here, if you look at this, minus J 2.5, basically it becomes plus J. So if the J imaginary or is at the bottom side, if it goes up, it will be if it's minus, it will be positive. If this is positive, it will be a minus value. Okay. Don't forget to change the polarity of the J value if you bring this J to the top. Okay. So this is basically a single equation. So we need to find another equation from node 2. So this is node 2, where we put V2 at the node here. So there's the current from V1 over here, we call it I1, and we have another current over here, dependent current 2Ix, and we need to assume another current over here that goes to the ground, and we call it I2. Okay, so use KCL to this node, so you get 2Ix, it goes inside, plus I1 equal to I2. So because this is going in, these two branches going in, so this we can plus it and equal to I2, which is where the current is going outside. So 2Ix plus I1 So I1 basically, because the current is flowing from V1 to V2, so that's why we write it like this: V1 minus V2 over J4, because there's a inductor over here between V1 and V2, equal to I2. I2 is V2 over J2, because there's another inductor over here connected to the I2 branch. So simplify it and you will get 2ix plus I1 equal to I2. Okay. So from the first equation, we know that Ix equal to V1 over minus J2. So we can insert it into the value for the second equation. Okay. Let's look back. Okay, let's look into here. So Ix here, I equal to Ix plus I1. This is the first equation for node 1. So Ix here is we define it as V1 over minus J 2.5. So we can use this equation to insert it inside the equation for node number 2. So after you insert it, you need to we call it to simplify it. So this simplify, so for this equation we simplify it where all this value at the bottom side will be J20. So for if we want to make this all this value underneath here, the bottom side value here is 20, J20. So this equation we need to times 10, this we need to times 5, and this we need to times minus 8. So then you get this value over here. So after you simplify it, you get this value for the second equation. So how to solve two equations? So you can use the calculator using Cramer rules, manually or using calculator. So insert all this value and you will get the value for V1 and also V2. Okay. I have checked the calculator, scientific calculator. I cannot insert complex number, so I'm not sure about your calculator. If you cannot insert complex number in the calculator using the equation function, you can use calculator from website to solve the equation. So let me show you an example using a calculator from website. So this website can solve a complex number using Cramer's rule calculator. So this is metric.redshift.com/Cramer. So here you can select the value of metric dimension. So for this question, we only have two equations, so it's a 2 metric dimension. So select 2 and set metric. So click complex number over here and insert the value of the equation inside this box. So after you insert all this value, so J, you need to change J to I, because in this equation you use I. So 1 plus 1.5i, 2.5i, 11, 15, 20, and click solve. So you get this answer automatically. You can also see the solution and how they solve the equation. So this is what you get when you do the Cramer rules manually. So the same answer will be given by the website calculator. So you can change the phasor form to the sinusoid form if the question asks you to do it. So you better read the question carefully. Sorry. So let's look into this example. So you have a circuit over here, and the question asks to compute V1 and V2. There's a voltage source, independent voltage source. We also have an independent current source. So if you remember about supernode, it says that if there's a independent or dependent current source between two nodes over here, so we already identified two nodes over here because it's connected all the branch to one node. So this will become a single node, which is a supernode. Okay. So how to solve a supernode circuit or analysis using supernode? So just remove all the resistor and the voltage source, and this will become a single node. Why we remove the capacitor? Because it is parallel to the voltage source. If you look at this, it's parallel with the voltage source, so that's why we can remove it, and it will become a single supernode. So we just use KCL, Kirchhoff current law, to this single supernode. So applying KCL at the supernode, we get the current I over here. We have another current over here, these two, and over here. So for this analysis, I just put the value. You can put I1, I2, and I3, but for this it's much simpler. Just put I for the capacitor, and then for the inductor, and inductor J12. Okay. So it's up to you on how you define it. You can put this one I, and this is I1, I2, and I3. And also don't forget to convert the sinusoid form to the phasor form. So this is already in phasor form. We already convert it. So if it's inductor, you just change it JWL. If it's capacitor, you change it to 1 over JWC. But for this question, it's already converted, so you don't have to convert it, because they already given minus J, 3, J6, and 12 ohm. So from the KCL equation, you change it for I minus J3, you change to V1 over minus J3 plus V2 J6 plus V2 over 12. So you need to remember that we still have two nodes over here, V1 and V2. So that's why we still use the V1 and the V2 over here. So this resistor and inductor connected to V2, and this capacitor connected to V1. Okay, then you simplify the circuit over here, do the operation, and finally you will get this equation, single equation. So then the second equation is we get it from this voltage source itself. We know that the potential difference between V1 and V2 is tan angular 45 degree. So we can write the equation as V1 minus V2 equal to tan angular 45 degree. So that's why we get this equation for the second equation. So V1 minus V2 or equal to V2 plus tan angular 45 degree. So you use Cramer rules to solve these two equations to get V1 and also V2. So if you want to use website calculator, you need to change this what we call change this to rectangular form with j value. Okay, so after you solve all the using grammar rules manually or using a calculator website, you get this value for v1, and v2 is this value. Okay, that's all for today. I hope you understand. If you are still not familiar with the nodal analysis, KCL or super node, so it's better for you to revise back your EP1, electrical principle 1, so that you will understand more about this analysis. So I will discuss further in tutorial next week. So thank you. Assalamualaikum and good afternoon.